Good evening. Let's wait for a few minutes so that others can join. We will be waiting just more 5 minutes, then we will start. So let's start. Remaining, I guess people will join soon. So today we are going to start with the week 2 assignment session. Myself, Anjali Ramashankar Prasad. I am a PMRF scholar at IIT ISM Dhanbad, and we are going to discuss problems related to the course on the NPTEL going on Essentials of Topology with the course ID NOC 24 MA 59, taught by Professor S.P. Tiwari. Okay, so let's start. So first of all, let's quickly go through some basic terminologies that you might have been seen in the lecture videos also. So first of all, what is cofinite subset of a set X? So for knowing about cofinite topology, we first want need to know about the cofinite subset of a set X. Okay. So what is cofinite subset of a set X? So if we have a set A, okay, so a cofinite subset of a set X is a set A whose complement in X is a finite set. Okay, fine. So if you have any set A, okay, that is subset of X, then we will say it as a cofinite subset if its complement, that is this part, is also finite. Okay, then only we will say A as cofinite subset. Fine. So you can imagine it as a, if we have a real number line. So if we are excluding this part and taking remaining as A, so its complement, that is this part, is finite. Fine. So since this is finite, so A will become a cofinite subset of this X. So once we have acquainted with cofinite subset, then what is cofinite topology? So the cofinite topology is a topology that can be defined on every set X. Okay, it has precisely, it will have precisely what elements it will have? Phi, that is empty set, and all cofinite subsets. We have seen what are cofinite subsets of X as open sets. Okay, so what will be the close subset? The only closed subset are finite sets. Fine. So this topology will contain which elements? That is empty set and X minus A that are finite. That is all complements of A that are finite. So those A will be in cofinite topology. Fine. I hope it is clear to everyone. Shall we move to the next topic? So the next definition is about co-countable subsets of a set X. Okay, so for knowing about co-countable topology, we need to know about the co-countable subsets of a set X. So what is co-countable subset? Similarly, like cofinite subsets, if we have a subset Y of X, so when we will say that this Y is a co-countable subset of X, if complement of Y is countable. Fine. So example, you can take if rational numbers you are taking as countable subset, then Q complement is what? You know that set of rational numbers is what? Countable subset of X. Then Q complement, that is set of irrational numbers, will be what? Co-countable subsets of X. Why? Because its complement, that is complement of irrational numbers, is rational numbers, and this set is what? Countable subset of X. So the set of irrational numbers is co-countable. Fine. So once you know about co-countable subset of X, then you can know about co-countable topology. So what is co-countable topology? The co-countable topology or countable complement, you can say, on any set X. What does it consist? It consists of X, phi, and all countable subsets of X. Okay. So all all co-countable subsets of X. That is those subsets whose complement will be countable. Fine. So the topology can be written in this way. I hope it is clear to everyone. So let's move to the next definition. What is order topology? The order topology on a totally ordered set X, comma, this is the topology tau generated by the set B defined by, we are taking this as the basis. Okay, I hope you are knowing about basis. We will see its definition later. So what kind of elements it will be consisting of? The set of open intervals, okay, then right ray and left ray. Okay, so this kind of sets, open intervals, are known as right ray, because this will start from a particular point A and it will extend till infinity in the right direction. Similarly, if it is going in the left direction, then it is called as left ray. Okay, so order topology can be of kind open intervals, open right ray, or open left rays. Fine. So for example, R with standard Euclidean topology is order topology. Fine. Where's the relation? Less than. Now what is lower limit topology? So the lower limit topology is what? Totally ordered set tau generated by this basis. Okay, where the elements will be of kind closed interval A to open interval B. That will be subset of X. Fine. So it will be closed from lower limit. That's why it is called as lower limit topology. Fine. I hope it is clear. Now let's move to the upper limit topology. So similarly for upper limit topology, it will be formed by the basis containing of elements like open at A and closed at B. Okay, so this forms upper limit topology. Okay, so the upper limit topology on a totally ordered set is the topology tau generated by this basis. Fine, so it will be closed on the upper limit. Okay, and then next comes our main idea, that is base for a topology. What is a base for a topology? So in the previous discussion session, we discussed about what are topological spaces and what are the conditions that should be satisfied for being a topological spaces, right? We have to satisfy three axioms. So you have some queries. I will request, if you have any query, if you are comfortable, then just please unmute yourself and you can ask the question. So someone is asking, what are the properties of these topologies? In what sense you are asking? Are you asking about the properties of topologies? As this is a comparison, can you please unmute yourself and let me know your query clearly? Open close sets. So so see, here if you have a lower limit topology, okay, so if you have been with the definition of topology, so what are the properties that should be satisfied? You know about usual topology, right? On R. So, okay. So, you know about usual topology on R. It is of kind open interval A comma B, right? Subset of R such that A and B are any elements of R, right? So, if you know about usual topology, so similarly, lower limit topology is also a similar kind of has a similar kind of basis, where our intervals are of kind closed at the lower end, that is at infimum end, It will be closed A, comma, and at the upper limit it will be open. Fine. So it will be kind, if we are taking on R, so this will look like some kind of like intervals 1 comma 2. Okay. So or then 2 comma 3. Fine. You can even take rational numbers. Okay. So in this way, if you'll take, if you'll try to satisfy all the three properties that we discussed in the last class for being any set, for being to be topology, what were there? First, that it should contain empty and x, right? So this will definitely contain that, satisfy that property. Then secondly, it should it should satisfy that all the members of the set should, if you take union, then its union should also belong to that set only. So if you take any kind of set of this kind, so its union will also belong in this set only, right? For example, if you'll take a real line, and here is A and here it is B, and if C is here and D is here, so its union is again of kind open at A and B, sorry, closed at A and open at B, right? Even if you take it disjoint, then its union is what? Again, you will get this union, this. It will be of kind disjoint, but separately, this will satisfy this, right? So, similarly, if you'll try for the third property, that is intersection, again, if you'll take the intersection of, take the same example here, intersection also is of this kind, right? Closed at C and open at B. This closed at C and B again belongs to this set, right? So this basis and the sets generated by these bases, you can form a lower limit topology. Okay, I hope it is clear now. Is it clear now, or any other doubt you have? Pardon? Can you please say again? Okay. Okay. So you are saying about disjoint unions, right? So if it is of this kind. Fine. So in this case, when you talk about tau open sets, if tau is generated by this basis, so if all these disjoint sets are separately forming the basis for elements in the basis, then you can consider it as a closed at A and open at like some other element B. So this is satisfying and this is also satisfying, right? And for disjoint, I was just explaining it. For disjoint, it will not satisfy. But if you are talking about a lower limit topology, right? So it is just a notation that the set will look like this, but you will have lots of such kind of sets, right? In this fashion, if you are taking the real line, so this kind of sets will be infinite, right? It is a topology. Here A comma B is belonging to what? X, right? So if you are taking it R, if A and B and belonging to R, so this A and B can be anything. It can be any real number. And how many real numbers do you have? Infinite, right? So you have infinite choices for this. This is just explaining that your base is generated by this kind of elements or this kind of intervals. Okay, so just let's get the definition of basis. Okay, so first let's be clear with the definition of basis. Have you understood? Okay, so let's see. First, be clear with the definition of basis. So that if you have x comma tau be a topological space and a class B of open subsets of x, there it was this of this kind, right? Okay, so this is open in lower limit topology. Okay, you can take that example. Okay, now that is the our B, that is basis, will be subset of tau, is a base for the topology tau if and only when if every open set G belonging to tau is the union of members of B. Okay, so if you are taking any open set or G from tau, then how you will define that? It will be the union of the members of B. Fine. And for n equivalently, you can say it as for any point P belong to G, if you have this set as G, if P belongs to this semi-open interval, then there exists B belongs to B such that P belongs to B and subset of G. That is, there should be some this kind of semi-open interval in our basis such that P belongs to this and this will be what? Again subset of our G, that is open set in tau. I hope it is clear now. So basically, if you are taking any point, then there should exist such semi-open interval, which will be subset of G that belongs to tau. Okay. So I hope it is clear now. Shall we move to the next topic? Okay. So now comes the term coarser and finer topologies. So what is coarser and finer topologies? So if you have two topologies tau 1 and tau 2 on a non-empty set X, that is two topologies you are defining on the same non-empty set X, and suppose each tau 1 open subset of X is also a tau 2 open subset of X. Okay, so that is if you are having some sets in tau 1 and some sets in tau 2. Okay, so each tau 1 open set will also be tau 2 open subset of X. Fine. That is, you can write it as tau 1 is subset of tau 2. So in this case, this tau 1 topology is coarser than tau 2, and tau 2 will be said as finer than tau 1. Okay, I hope it is clear. So I hope all the basic terminologies for the current discussion session is clear to you. So we will move to the questions. Okay, if you have any doubt, so you can write. Shall we proceed? Okay. So your first question is here, that let tau be a topology on natural number set which consists of empty set and all subsets of natural numbers of the form En, that is equals to this kind of set. Okay, n comma n plus 1 comma n plus 2 comma dot dot dot, where n belongs to natural numbers. Okay, so then which of the following subsets of n are closed subsets of natural numbers? Okay, so you have to find which of the following subsets will form the closed subsets of n. So is it only natural number set or empty set or this whole or none of the above? So find out which of the following are the closed subsets of n with respect to this topology. So everyone please try and let me know the answers you got. Yes, n and phi are always open. So you have to find which are closed sets here. So is it C or none of the above? Everyone got the answer as C, right? Shall we proceed to the answer? Okay. So yes, the answer is correct. That the correct option will be C. Why? Because a set is closed if and only its complement is open. Okay. So here we're having sets of kind En is equals to n comma n plus 1 comma n plus 2, right? So what will be even? It will be 1, 2, 3 and so on. Then E2 will be 2, 3 and so on. Then E3 will be again 3, 4 and so on, right? So we have open sets of this kind. So what will be closed sets? Its complement. So here its complement will be empty set. Here its complement will be singleton one. Then here it will be 1 comma 2. Similarly 1 comma 2 comma m, right? So in this fashion you will get that this forms the set of closed sets. Okay. I hope it is clear. Okay. So let's move to the next question. So second question is that consider the following topology on X. X is given as set of A, B, C, D, E, and we have tau as this set. It comprises of X, empty set, singleton A, then element A and B, then ACD, then ABCD, and ABE. Okay. Then which of the following subsets is or are closed subset of X? So you have to find that which of these following options and the sets in that forms the closed subsets of X. So is it BC or B, that is empty X and AC, or option C comprising of these sets, or option D comprising of these sets? Okay, so solve it, find which are the closed subsets of X, and let me know your answers. So yeah, you have to use the same logic and you will get the answer. So I hope this concept is clear how to find the closed sets. Okay, so shall we move to the answer? Okay, so again, a set is closed if and only its complement is open, right? So come here, you can see complements of this. You have to find the complements of this. Now for, you have to discard also. Why A is discarded? Because if first of all find its complement, so here you will get first empty set, then complement of this you will get X, then complement of this you will get B, C, D and E. Then next you will get C, D and E. Then next you will get C and B and E. Wait a minute. I'll come to your question. Then the next you will get E, and then next you will get, okay. So basically for finding the closed subsets of X, you need to find the complements of open sets of X with respect to tau. Okay. So what are the open sets with respect to tau? These all sets that are forming tau. These are all tau open sets, right? So basically you have to find its complement, and all those complements will be closed sets. Okay. So those will not be the part of tau, right? The complement of tau open sets will not be the part of tau, right? I hope it is clear. So basically you have to find its complement. These are the tau open sets. So what is the complement of X? That is phi. Then complement of phi you will get X. Then complement of A you will get it as B, C, D and E, right? Then complement of AB you will get C, D, E. Then ACD you will get B and D. Then ABCDE D you will get E. And then ABE you will get CD, right? So let's see. For the first option A, this B comma C, does it belongs to any of this? It is not there, right? So this is incorrect. Okay. What are you, complement does not belong to tau. That I explained, right? So, okay. This is the second session. First, I have uploaded also the YouTube link, and the PPT slides have been also shared with you. Fine. Shall we continue? Okay. So now here you will get this closed sets, right? So first one gets excluded, although B comma C does not belongs to this set, but it is not neither complement of any of this tau open sets, right? So this is excluded. Now similarly second one, MT and X, this belongs to this closed sets, but A comma C, it is not there, right? So this option is also discarded. Similarly for D, we are having here A, B, E. It is also not there anywhere, right? So this option is also discarded. And here you can see for C option, B, C, D, E also there. C, D, E is also there and B, E also there. Okay. So the correct option is C. I hope it is clear how we got the closed sets. Is it clear to everyone? Shall we move to the next question? Or if you have any doubt, you may ask. Okay. So if you don't have any doubt, let's move to the next question. So the next question is, you are having an interval G of this type, closed 8 comma 15 and opens. Okay, so then you have to find which of this satisfies. So is it option A, that is G is open under upper limit topology on R, or option B, that is G is open under lower limit topology on R, or C, that is G is open under usual topology on R, or D, that is none of the above? So everyone please try it and let me know your answers. Some may have got the answer, but let others also try. And okay, once we will be with everyone's answer, we will move to the answers. Everyone try it. If you have any doubt, you can ask. Okay, some are saying B, that is lower limit. What about others? Yeah, by definition, you are saying. Others also, is it B, that is lower limit topology? Others, have you got it? Or you are facing any difficulty? Just recall the definitions of lower limit topology, upper limit topology, and usual topology, and see which of these is satisfied by G. Okay, you are saying that it should include questions from CSI exam. So actually, it is the discussion session of NPTEL, and it is about to be like not a that high quality of questions, because its difficulty level will be much higher. So we have to solve basic questions, and if you have any doubts, you can discuss. We can discuss if you have any problems. Is it fine? Okay, we will try. Okay, we will try. Let's see. Further, the main idea of this discussion sessions is to focus on that the problems should help to solve you the assignment problems that are in the sheets. So basic idea is that you should learn something from here. Okay. Okay. So shall we move to the answer? Okay, so let's proceed with the answer. So yes, by the definition of the lower limit topology on a total ordered set, that is, it consists of the elements in the bases as closed at A and open at B. So definitely by the definition itself, it is clear that J is open under lower limit topology on R. Fine. Is it clear? Okay. So let's move to the next question. So next question is that let X is equals to set 1, 2, 3. Then when which of the following forms a cofinite topology on X? Okay. So you have to find that which of these following topologies, whether it is A, B, C or D, forms a cofinite topology on X. So verify which of these is a cofinite topology on X. Everyone try it and let me know the answers. Just stick to the definition of cofinite topology and try to get which of these topologies form the cofinite topology on X. That is a set of 1, 2, 3. Okay. For you're saying for finite sets, cofinite topology. You wrote something? Okay. Option D, you're saying because X finite, it will be discrete. Okay. For finite sets, cofinite topology is same as discrete topology on the set. Yeah. So I guess you got your answers. Yes. By definition, it's a yeah. So you even have to discard this other options by using the definition. So did everyone got their answers? If anyone is having any doubt, you can ask or we shall move to the answer. Shall we proceed? Yes. So yes, the correct answer is D. The complement of all the subsets of X are finite here. Okay. Here if you see D, option D, it is a discrete topology. Fine. So obviously, as X is finite and this is a discrete topology, so all the complements will be automatically finite, right? So this satisfies for being a cofinite topology on X. Why A is discarded? Yes, yes, you can ask in Hindi. So yeah, why we discarded option A, B, and C? Because they are not even forming topologies, right? So here you can see here the intersection, that is singleton 2 does not belongs to this. Then here its union does not belongs to this. So this does not form topologies. This also does not form topology. So the correct option is D. Okay. So I hope it is clear to everyone. Let's move to the next question, shall we? Okay. So the next question is, consider the lower limit topology tau. Okay. So consider the lower limit topology tau and standard topology tau dash on R. So you have to consider two topologies tau and tau dash on R. Then which of the following statements is correct? So tell me which is correct. Is it option A, that is tau dash is finer than tau, or B, that is tau is finer than tau dash, or C, that is tau dash is coarser than tau, or D, that is both B and C? Let me know your answers. Everyone tried. So what is the answer you're getting, everyone? Others, some are getting option D, and what about others? Try it. Just recall the definition of being finer or coarser topology and try with the definition of lower limit topology and standard topology on R and see what you're getting. Is it A, B, C, or D? That is both B and C. So you are saying, okay. So by this you are saying that lower limit topology is finer. So what is your answer? Which option is correct? A, B, C, or D? Both B and C, right? So hope everyone is with their answers. Shall we move towards the answer section? Or is there anyone still trying? We will discuss it. Let's other also try, then we will come to the answer and we will discuss it. Is everyone ready with the answers? Shall we proceed? Okay. So yes, correct answer is both B and C. Uh, because the lower limit topology is finer than their standard topology because every open interval can be written as a countably infinite union of half open intervals, right? So if you will take any half open interval, then if you are taking any open interval a comma b, so it can be written as union of countably infinite union of any such half open intervals. Fine. So in this way, your logic is also correct. So you will get that every lower limit topology is finer than the standard topology on R. Okay. You can simply get it with the counter example that open and closed interval 0, comma 1. This is not open in standard topology, right? If you have to say that this is finer, then this should also be open in this, but it is not, right? So in all the ways, you got that lower limit topology is finer than the standard topology on R. Yeah, so the logic is this, that so if you have R and you have two topologies tau and tau dash, okay, one is with the lower limit topology and other is the our standard topology, okay. So the logic behind it is that every open interval like this, that is usual, this can be written as union of such kind of intervals. Simply you can take a real line and take any open interval a comma b. Okay. So how you can construct this? You can take union of such sets, right? Fine. So if you will take union of such sets, you will get again your open intervals a comma b. I hope it is clear. So let's go to the definition of basis first. Wait, let me clear all this. Wait. So for basis, what you need? If you are taking any element P from G, so from basis you should get B such that P should belong to that B and B should be subset of our G, right? So first of all, take these our semi-open intervals. So for any element P, if you are taking from R, so you will get such B, right? That will be subset of our G. Okay. Similarly, for this usual also, you will get some B dash. Okay. That is subset of some G dash that belongs to our topology tau. G dash belongs to our topology tau dash and this belongs to our topology tau. Fine. Now, just stick to that. These kind of basis elements, will it be subset of this or this kind of basis elements will be subset of this B? Just clarify that thing. You will always get this open intervals as subset of these kind of intervals, right? I hope it is getting you a little bit. Thus, open intervals A comma B will be subset of these kind of intervals, right? Always. So these topology, that is elements in topology tau, okay. So you are saying that, yeah, you got it. If you are taking it set of kind A minus 1 by n, so it will tend to what? A, na? Open interval A, right? So its union will be open interval A comma B. Is it clear? Yes, you got the logic right, that if you are taking it as A minus 1 by n comma B and just take its arbitrary union. Yes, your logic is correct. That you can even think in the form of basis, or simply if you are taking, as you said, the intervals of kind closed A minus 1 comma n 1 by n comma open B. So its arbitrary union over n will be what? N belongs to natural number take. So it will be open A comma B. Is it clear? So any ways you can go, either by the basis or by taking arbitrary union. You just need to find a particular kind of intervals. Okay. Or you can simply go by this example also, that close 0 comma 1 Any logic that you are comfortable with, but just get it cleared. What about others? Is it clear now? Or still having doubt? Simply you can think about this now. Close interval 0, comma open 1. It is not open in standard topology. Fine. So obviously lower limit topology will be finer than standard topology, right? Okay. Yes, you try to prove it. Union of 1 minus 1 by n times a plus 1 by n times b, comma b. Okay. You are just expanding those terms, just increasing the values. Either way, you might have defined it as that union. You can define it as any way. I hope it is clear now, everyone. Is there anyone still facing difficulties? Shall we move to the next question? Okay. So your next question is, state whether the following statement is true or false. So if x, your statement is, if x is any non-empty countable set, then the discrete topology is the co-countable topology. Is it true or false? You're saying that you tried to prove that this is not an open set in use. It is by definition not open set in usual topology, na? Why do you need to prove it? By definition, only you can see that it is not open in usual topology. Because in usual topology, you have sets like open A, comma B, right? Here it is closed at 0. So how will be it open set in usual topology? Yeah, only open sets, tau open sets you are talking about, na? So in usual topology, tau open sets are what? Open A, comma B. So here this example is not even satisfied there, right? Okay. And the answers you are saying that it should be false. Just check it. Is it true or false? Everyone? Others, what you say about this question? Is the statement true or false? I again read the statement since handwriting may not be comfortable with you. So if X is any non-empty countable set, then the discrete topology is the co-countable topology. Okay, so you have any non-empty set X that is countable. So whether the discrete topology is the co-countable topology here on X. Just read the question clearly. Okay. So we are saying it is true. Okay. So is everyone ready with their answers? Yeah. Is there any doubt to anyone? You can ask, or we, if there's no doubt, then we will move to the answer. Shall we proceed? Okay, try it. Read the statement and tell me what will be the answer. Is it true or false? I guess we did the example on this statement. Yeah, all subsets of countable sets are countable. So their complement will be again countable, right? So this works. Okay, so you got also true. Okay, so let's move to the answer. It's clear now to everyone. So answer will be true because the here we have set as here our set X is countable. So obviously it's any subset if you will take, then its complement will be again countable. So this is true. I hope it is clear. Shall we move to the next question? Okay, so you are saying that if we take an uncountable set, okay. So here what we have, basically we have a non-empty set that is countable. So and our topology is discrete topology. That is all the it will consist all of the subsets of X, right? Now here we were having countable sets, so its complement will be countable. Now what about uncountable sets? So if you are having uncountable, if you will have uncountable set, then you cannot say about its complement, right? Complement about every set, right? And in that case, if X is, you are saying uncountable, right? 1, 2, 3, up to it will go on till infinity. So by the definition of discrete topology, if you take any subset of this, you can take any subset, right? So one is also part of this topology since it is a discrete topology, and its complement will be, let me explain it first. So if you are taking a subset 1, then it complement will be what? 2, 3, up to infinity. So is it countable? And here, if you take X as R, that is, here will be rational numbers also will be there, not only the natural numbers. So now, is this set countable? Yeah, we are taking it rational numbers. Is it? We are saying that. Okay, let's go one by one with your questions. First, she was asking that if we take uncountable at place of countable, so it will not work, right? Because if you'll take any countable subset of that uncountable part, then its complement will be uncountable, right? So in that case, it is not true. Now again, you are saying that if you take set Q, not always, but the question stands for general, right? For example, here, okay, construct your example and let me know that where you think that, do you have any such example where you think that if you take an uncountable set and discrete topology, then it will be co-countable? Yes, we can never get it as co-countable. So if you are having doubt in that, then you just construct example and we will discuss on it. And again, you were saying about this, the discrete topology and Q is co-countable. So what is complement of, if you say take any set of rational numbers, then its complement is what? You said now that let's take Q as count. Yes, every subset of Q is countable, but we are talking about co-countable, right? So co-countable means what? Its complement should be countable, right? So is the complement of Q countable? What is the complement of Q? Yeah, we are talking about discrete topology on Q, and you have to see, listen. Yes, you can speak. You can just unmute yourself and let's discuss it. That will be better. Ma'am, Yes.
Ma'am, actually, if you're talking about topology on R, in that case, the complement of Q is uncountable. But if you are taking discrete topology on Q, then we are taking the set as Q. Q is countable set and every subset of Q will be countable. So in that case, it is easy to understand that the topology, discrete topology is co-countable.
See, we are saying that, listen, what we should have any X non-empty set, and you are saying that we are taking it as Q, right? Then we have to take complement in R, na? We are taking any discrete topology. Okay, so your element will be subset of Q. Then its complement will be irrationals. Now, irrationals are countable. Complement in R. Complement in R. Pardon? Okay, just a minute. I can't hear you. Let me connect. Just a minute. Just a minute. I need to connect the earphones. Am I audible now? You can speak your what you think. Problem is from your side. Can you please be louder? Take your mic nearer. Mic louder. तो एक काम करो आप मतलब लिख सकते हो. You can just write it there. Try without mic, like directly from phone. You heard what you were saying. Yes.
मैम टोपोलॉजी जिस सेट में डिफाइन कर रहे हैं उसी में तो कॉम्प्लीमेंट लेंगे ना.
कॉम्प्लीमेंट उसमें नहीं रहेगा. कॉम्प्लीमेंट उससे बाहर रहेगा, राइट? हाँ,
मैम
टोपोलॉजी.
आपकी आवाज नहीं आ रही.
ओके. क्या कह रहे हो? टोपोलॉजी किस पे डिफाइन कर रहे हो? क्यूब पे डिफाइन कर रहे हो या एक्स पे डिफाइन कर रहे हो? सी, हमने you're saying if we take Q in
यस
case
मैम.
of countable topology, it will be discrete. So for co-countable topology, it must be uncountable, right? So first of all, for co-countable topology, what do you want? From the set, if you are taking any substance, then its complement should be countable again, right? Let's just discuss your doubts clearly. Mm. So can anyone elaborately discuss what steps you are taking? Am I audible to you guys? Okay. So, okay. So let's take without. Okay. Now let's consider X as real number set. Let's go one by one. So we are taking X as, is my voice breaking? Let me just remove it. Am I audible now? Okay, so let's take one by one. Let's consider your x as, okay, is it clear? So if you're taking x as your real number set, so if you're taking a subset q, okay, so it will be countable. But what it's about its complement, it will be irrational. Okay, so in that case, you cannot talk about the co-countable. But if you are taking q complement, that is set of irrational numbers, yes. But if you are taking set of irrational numbers, then in that case, the complement will be what? Countable, right? So in that manner, yeah. So if you are taking q complement, then you can talk about co-countable topology. I hope it is clear now. Everyone still facing any doubt?
मैम
हाँ बोलो.
हेलो
हाँ.
मैम ये बोल रहा हूँ कि अगर मान लीजिए हम 2 सेट ले रहे हैं तो कॉम्प्लीमेंट उसी सेट में लेंगे या फिर बड़े सेट में लेने चले जाएंगे, या तो फिर उसमें हम सब स्पेस टोपोलॉजी डिफाइन करें?
नहीं नहीं, सबस्पेस टोपोलॉजी की तो बात नहीं हो रही ना, अभी तक हमने सबस्पेस टोपोलॉजी की बात नहीं करी, राइट? अभी तक हम सिर्फ टोपोलॉजी में है. ओके,
यस मैम।
सो लेट्स बी स्टिक टू दैट. सो टोपोलॉजी के लिए आपके पास एक सेट एक्स रहेगा और
जी।
उसको लेके आप डिफाइन करोगे टाउ, राइट?
हम्म,
तो टाउ के अंदर कौन से सेट्स रहेंगे? टाउ जो क्लास है उसके अंदर कुछ सबसेट्स रहेंगे एक्स के, जो टोपोलॉजी डिफाइन करेंगे एक्स के ऊपर, राइट?
जी।
तो
यस
जो
मैम।
आप सबसेट्स लोगे वो कहाँ से लोगे? टाउ से लोगे और चेक करोगे कि,
एक्स से
हाँ,
एक्स से सबसेट लेंगे ना?
आप टाउ में से सबसेट्स लोगे.
जी।
ओके,
ठीक है मैम, मैं समझ गया आप क्या कहना चाह रही हैं। आप एक्स आर ले रही हैं, फिर उसमें क्यू को देख रही हैं आप।
हाँ, ठीक है.
ठीक है, ठीक है, ओके, थैंक यू।
Clear to everyone? Shall we proceed? Seher, do you have any doubt?
I was talking about if we take x as q, then it will displace the topology on q will become the co-counted column. And,
You are taking x as q.
yes, ma'am. In that case, it will become co-countable topology.
Yes,
And if we
yes. In
take
that
x as
case, you
r,
will. Yeah, in that case, you will take it will become co-countable.
yes, ma'am. Yes, ma'am. That was my point.
Yeah, if you take x as q, then it will form as co-countable topology. Any other questions?
काउंटर के केस में ये काम करेगा ना, एक्स को आर ले लें हम।
x को r ले लो आप.
काउंटर एग्जांपल फॉर काउंटर एग्जांपल।
हाँ हाँ, ठीक ठीक, काउंटर एग्जाम्पल के लिए काम करेगा.
यस मैम, आगे बढ़िए।
ठीक है, तो नेक्स्ट क्वेश्चन पे जाए. Okay, sir, let's move to the next question. So the next question is, let x is equals to this set A, B, C, D, E, let tau be an arbitrary topology defined on x, then which of the following forms basis for tau? Okay, so here is your question that this is a set x comprising of A, B, C, D, E, and tau is arbitrary topology defined on x, then which of the following class of B will form a basis on tau? So verify which is forming the basis for tau. Is it A, B, C, or D? Everyone try it. So again, I'm repeating the question that you have set X with elements A, B, C, D, E, and tau is the arbitrary topology. You have to find which of this class of B forms basis for this tau. Let me know your answers. So you're all saying B. What about others? Okay. So other options don't satisfy the definition of basis, right? So everyone is in it. There does not exist any element which contains singleton set. That is not a problem, na? Whether there is a singleton set or not. You also have to tell me why other options are discarded. Not only why B is the answer, but why other options are discarded. We are saying that there does not exist any element which contain singleton set. यहाँ D में तो है. We have elements that are singleton sets. हाँ.
सिंगलटन सी कहाँ कंटेन करेगा? कोई है क्या इसमें?
क्या चीज?
सिंगलटन सी
तो उससे ये बेसिस नहीं होगा क्योंकि सिंगलटन सी नहीं है तो. मान लो
बेसिस में क्या होता है कोई? जी
मान लो इसमें
जी
सी होता, ठीक है,
yes.
तो क्या वो बेसिस हो जाता?
और देखना पड़ता है, मतलब एक प्रॉपर्टी है ना, इस तरह कह सकते हैं.
क्या प्रॉपर्टी है?
कोई भी सेट ले, टोपोलॉजी में कोई एलिमेंट ले और उसमें उस सबसेट में, हेलो,
हाँ हाँ, आ रही है आपकी आवाज, बोलो.
उस टोपोलॉजी का कोई एलिमेंट ले मैम, और फिर उसमें उसमें एक एलिमेंट लें, तो फिर बेसिस में एक एलिमेंट मिलना चाहिए कि उस एलिमेंट को कंटेन करे और उस सबसेट में कंटेन हो. तो अगर सिंगलटन सी अगर हम लें एलिमेंट, तो उसमें सी
सिंगलटन
बिलोंग
सी
करेगा.
एलिमेंट नहीं होगा ना. एलिमेंट क्या होगा? एलिमेंट आपको कहाँ से लेना है?
टोपोलॉजी से लेना है.
नहीं,
हाँ,
एलिमेंट आपको एक्स में से लेना है, राइट?
टोपोलॉजी का एलिमेंट मैम, टोपोलॉजी से कोई सबसेट, मतलब एलिमेंट जो होगा टोपोलॉजी का वो कोई सबसेट होगा, फिर उस सबसेट में हम
एक
कोई
मिनट,
एलिमेंट लेंगे.
एलिमेंट कहाँ से लोगे आप? सबसे पहले मुझे
ये
बताओ, एलिमेंट
टोपोलॉजी
कहाँ
के
से लोगे? टोपोलॉजी में से लोगे या एक्स में से लोगे?
टोपोलॉजी में जो एलिमेंट्स होंगे वो सबसेट्स होंगे मैम, फिर उस
हाँ.
सबसेट में कोई एलिमेंट एक हम लेंगे,
नहीं
फिर कोई एलिमेंट बेसिस में ढूंढेंगे जो उसको कंटेन करे और उस सबसेट में कंटेन हो.
नहीं, आपने स्टार्ट ही गलत किया. आप जो एलिमेंट लोगे, ठीक है,
हम्म.
एक्स लोगे, वो कहाँ से लोगे? एक्स में से लोगे, ठीक है.
अच्छा, ठीक है, ठीक है. जी
और जी आपका रहेगा टोपोलॉजी में.
जी,
एक बी होगा जो कहाँ बिलोंग करेगा? आपके बेसिस में,
ठीक है इसमें.
ठीक है. तो हर एक एलिमेंट एक्स के लिए आपको बेसिस में एक बी मिलना चाहिए, ठीक है, जो
जी
किसका सबसेट होगा? जी का.
जी, और एक्स जी में भी बिलोंग करना चाहिए.
किसमें?
जी में भी तो बिलोंग करना चाहिए ना
तो
स्मॉल एक्स।
बी में अगर बिलोंग करेगा तो जी में तो करेगा ही, राइट?
जी
ठीक है,
ठीक है जी।
सो चेक लाइक दैट. So why are you discarding C, D or A? Let me know why are you all discarding other option. B is the option, correct option. You all guessed it right because it is a discrete. मतलब it is singleton sets, right? So it will form basis. Why you are discarding other options? Let me know about that. That is the matter of discussion. Anyone? Yeah, so you are saying that the second property of basis that for intersection of two basis element there exists a third one contained in the intersection. Correct. So according to this property हम बोल सकते हैं कि sum of the options that is A, C and D does not work. Okay. So यहाँ पे क्या हो रहा है? In first case, if you are taking intersection of these two, that is B, that is not belonging to B itself, right? बिकॉज इसको भी तो वो प्रॉपर्टी सेटिस्फाई करनी पड़ेगी यूनियन की और इंटरसेक्शन की, राइट?
यस मैम क्लियर।
हाँ,
यस
यहाँ पे क्या होगा? सेम यहाँ पे भी आपके पास सिंगलटन बी आएगा जो नहीं है. अगेन फॉर डी यू विल गेट इंटरसेक्शन एज सिंगलटन डी विच इज नॉट देयर, राइट? So because of this reason that it is not satisfying the property of that intersection of any two elements in B should be again in B. That's why we are discarding A, C and D. Okay. So our answer is B. Okay. बाकी सबके लिए क्या हो रहा है? आपको इंटरसेक्शन सेटिस्फाई नहीं हो रही है. क्लियर? सो जैसे कि फर्स्ट एग्जांपल में आप देख सकते थे, यू हैड बी. ओके, सो यू हैड बी एज दिस क्लास हियर. अगर आप कोई भी दो सेट्स ले रहे हो, ए बी एंड सी डी, सो इट्स इंटरसेक्शन विल बी सिंगलटन बी, राइट? एंड दिस इज नॉट यूनियन ऑफ मेंबर्स ऑफ बी बिकॉज किसी भी एलिमेंट्स का आप यूनियन ले लो वापस बी नहीं आ रहा है. इट इज नॉट दैट कि आपको इंटरसेक्शन करके दैट एलिमेंट शुड बी देयर. प्रॉपर्टी क्या होनी चाहिए कि जो इंटरसेक्शन करके आपको मिल रहा है वो किसी ना किसी मतलब बी का अगर आप कोई भी एलिमेंट्स का यूनियन ले रहे हो तो आपको वो इंटरसेक्शन मिलना चाहिए. ठीक
यस
है,
मैम क्लियर।
तो वो चीज सेटिस्फाई नहीं हो रही है. ना कि इसलिए क्योंकि खाली इंटरसेक्शन वाला एलिमेंट इसके अंदर नहीं है, जरूरी तो नहीं है सारे इंटरसेक्शन वाले एलिमेंट्स इसके अंदर होंगे, बट हाँ आपको यूनियन करके एटलीस्ट वो इंटरसेक्शन वाला एलिमेंट आना चाहिए जो कि क्लियर नहीं है, यहाँ पे सेटिस्फाई नहीं हो रहा है. क्लियर? Is everyone clear with the problem? Why we are discarding other options? Okay. So shall we move to the next question? That is our last question. Others, some are not responding. Are you still trying or stuck somewhere? Remaining? Are you there or still trying? Or if you have any doubt, if you have any doubt, you may ask. Then we will proceed to the next question. Don't be shy. Is it is a discussion session. So whatever your doubts are, you can discuss, even if it is a basic one.
मैम डाउट्स आपके ईमेल में भेज सकते हैं क्या?
आपका एक डिस्कशन फोरम है, राइट, जहाँ पे आप कोर्स
यस
कर रहे
मैम।
हो? डिस्कशन फोरम पे Q&A करके है, राइट? आपने चेक किया है?
जी जी।
हाँ, तो उस
जी
पे
मैम
आप अपने
देखा है।
डाउट्स उस पे आप अपने डाउट्स पोस्ट कर देना, आप वहां पे क्लियर कर दिए जाएंगे. ओके.
ओके ओके।
Okay, so let's move to the next question if you don't have any doubts further. So the last question is, consider the lower limit topology tau on R having basis of this kind. Then which of these following options satisfy? That is minus infinity comma tau 2 is a tau open set, or closed minus 6 comma 4 is tau open set, or R is tau open set, or all of the above. Everyone, please answer it. I hope after so much discussion of on lower limit topology, you may be clear with this answer. It is quick answer. Okay, we have some more questions further. Okay, so I hope it is clear to everyone why it is D. So let's move to the next question. Okay, so by definition only, you will get that all this satisfy to be a lower limit topology's element. Okay. Um, So consider a non-empty set X and consider the following classes and determine which of these forms a basis for a topology tau 1 X. तो इसमें से कौन सा बेसिस फॉर्म कर रहा है बताओ, ऑप्शन 1 या 2? Okay, so you're asking, ma'am, if we take Q minus finite set in tau, then it will also form cofinite topology. तो Q minus कोई finite set अगर आप करते हो तो again it will be rational number set, right? हाँ, x आपने Q ले लिया है, आपने टाउ में से कुछ एलिमेंट्स लिए हैं जो किस तरह के हैं, Q माइनस सम फाइनाइट सेट, राइट? तो Q माइनस फाइनाइट सेट लोगे आप, तो जो मिलेगा आपको वो भी तो रैशनल रहेगा. तो क्या उसका कॉम्प्लीमेंट, तो क्या उसका कॉम्प्लीमेंट फाइनाइट होगा? व्हाट इज योर आंसर्स? यस. हाँ, Q के साथ भी होगा कोफाइनाइट टोपोलॉजी विथ रिस्पेक्ट टू दिस डेफिनेशन, अगर आप जा रहे हो तो. क्योंकि अगेन आप वही कर रहे हो ना, Q में से आप एक फाइनाइट सेट्स निकाल के अगर आप टोपोलॉजी बना रहे हो तो जस्ट चेक करो कि उसका कॉम्प्लीमेंट भी क्या होगा, फाइनाइट होगा। मतलब वो जो आप फाइनाइट एलिमेंट्स को माइनस कर रहे हो, दैट विल बी योर सेट, राइट? सो इट विल फॉर्म। Okay, so you are saying the correct option is both. Some are saying C, some are saying D. What is the correct answer? So is it C or D? So ये किस तरह का है? This is what? This is forming our ray topology we discussed, right? Right ray. And this is basically our left ray. Okay. So this both will form basis for the topology on X.
मैम यदि इंटरसेक्शन लेंगे दो एलिमेंट्स का,
हाँ,
तो फिर क्या वो आएगा इसमें?
तो
जैसे
इंटरसेक्शन
एक
कैसे दो एलिमेंट्स के लोगे आप?
सपोज एक हम ले 1 टू इंफिनिटी और एक ले 2 टू इंफिनिटी, इनका इंटरसेक्शन ले,
तो
तो फिर वो
आप
एक तरफ से
ले
क्लोज
रहे हो
हो
1 टू
जाएगा।
इंफिनिटी एंड 2 टू इंफिनिटी, ठीक है? तो पहले आपको x भी डिफाइन करना है और टाउ भी डिफाइन करना है। आप x क्या ले रहे हो मुझे ये बताओ।
नेचुरल नंबर का सेट ले लेना।
x आपने नेचुरल नंबर का सेट ले लिया। टाउ, टाउ तो इसी से बन रहा है, बेसिस से, राइट? तो इसका
यस
आप
मैम।
इंटरसेक्शन लेने की बात कर रहे हो।
जी।
पहली बात, आपको यहाँ पे किस तरह के एलिमेंट्स लेना है? जो इंटरवल फॉर्म करे, राइट? n तो डिस्क्रीट हो जाएगा।
यस मैम। तो आर ही लेके चलेंगे, मतलब
तो आप
आर
अगर
ही
r
लेना ही,
ले लो तो
आर ही लेना पड़ेगा या कोई और भी हो सकता है?
इरेशनल्स रैशनल्स ले सकते हो आप, जो डेंस हो वो लो, जो डेंस हो।
तो फिर वो अगर कोई भी हम लेंगे, मान लीजिए कोई इंटरवल लेते हैं, तो उसमें तो सारे एलिमेंट्स होंगे ना। सपोज आप क्यू कॉम्प्लीमेंट ले लेंगे तो उसमें क्यू भी।
इवन इफ आप n भी ले लेते हो, ठीक है? तो क्या होगा?
यस मैम।
1 कॉमा इंफिनिटी और 2 कॉमा इंफिनिटी का यूनियन क्या होगा? अगेन 1 कॉमा
तो
इंफिनिटी आ जाएगा।
इंटरसेक्शन इंटरसेक्शन।
और इंटरसेक्शन लोगे तो क्या आएगा? एलिमेंट खाली 2 आएगा, राइट? है ना?
नहीं, टू उसमें है ही नहीं, टू नहीं है उसमें ना। टू ओपन है मैम।
Yes, तो open है कि one infinity intersection two infinity. दोनों open है तो the intersection will be two infinity.
आप थोड़ा लाउडली बोल
Common
सकते हो?
now the common goes two to infinity. So obviously it will be the intersection. It is easy. We can check on real line itself.
या
Yes.
यू हैव टू चेक इट ऑन रियल लाइन, क्योंकि ये इंटरवल है। तो आपको इंटरवल के अंदर के हर एक एलिमेंट के लिए आपको सेटिस्फाई कराना ही है ना, तो नेचुरल नंबर्स के लिए तो होगा ही नहीं, क्योंकि सिंगलटन आ जा रहा है जो इसमें बिलोंग ही नहीं करता है। इंटरवल का डेफिनेशन ही क्या है कि हाँ,
Natural numbers and this will also form basis, but वहाँ पे they will not act as interval. वहां पे वो डिस्क्रीट सेट आ जाएंगे, बट
हाँ
इट विल अगेन फॉर्म some equations there also.
हाँ, मतलब वो डिस्क्रीट फॉर्म में आ जाएंगे। ठीक है।
यस मैम, यस मैम।
सो इन बोथ द केसेस इट विल फॉर्म a basis for the topology. Okay. First one basic definition है right ray का, और next वाला definition है left ray का. Okay. So let's move to the next question as we have already crossed the time limit. So the last question is, consider the cofinite topology tau and the usual topology u on the plane R2. Then which of the following options is or are correct? So tau is coarser than u, or u is coarser than tau, or tau is finer than u, or both B and C. So please be quick and let me know your answers. So what is your answers? A, you are saying tau is coarser than u. Others? A. So let's see what is the correct answer. Yes, it is A. Tau is coarser than u, क्योंकि every finite subset of R2 is a U closed set, right? So by definition only, अगर आप कोई भी complement of finite subset लेते हो R2 का, मतलब वो tau ही हो गया, tau का member हो जाएगा, तो वो again it will be U open set, right? So you will get tau is coarser than U. I hope it is clear. Is there any doubt in this question, or still trying?
थोड़ा डायग्राम बना के बताइए।
Okay, so let's see it. Okay, आपके पास प्लेन R2 है. Okay, यहाँ पे आपने कोई भी कोफाइनाइट टोपोलॉजी लेनी है. कंसिडर कोफाइनाइट टोपोलॉजी टाउ एंड यूजुअल टोपोलॉजी यू ऑन दिस प्लेन R2. तो यूजुअल टोपोलॉजी किस तरह की रहेगी? मान लो कुछ
सेट डिस्क ले लें
कुछ
या
ओपन इंटर
रेक्टेंगल ले
कुछ
लें।
एक
ये
ओपन ओपन डिस्क है, ठीक है. और कोफाइनाइट टोपोलॉजी किस तरह की रहेगी कि आप कोई भी अगर आप सेट ले रहे हो तो उसका कॉम्प्लीमेंट क्या होना चाहिए? फाइनाइट होना चाहिए. ठीक है, तो डेफिनेशन पे जाइए. कोफाइनाइट टोपोलॉजी के हिसाब से आप कोई भी सेट अगर इस प्लेन में ले रहे हो तो उसका कॉम्प्लीमेंट फाइनाइट होना चाहिए. ठीक है, तो आप ऐसा तो कोई सेट ले नहीं सकते हो, मतलब ट्रायंगल हो गया या स्क्वायर हो गया, ऐसा कोई सेट नहीं ले सकते ना, क्योंकि इसका कॉम्प्लीमेंट क्या हो जाएगा, पूरा का पूरा R2 हो जाएगा, राइट।
यस।
तो आप ऐसा सेट नहीं ले सकते हो। आप कोई ऐसा सेट लोगे जी जिसका कॉम्प्लीमेंट क्या हो, ये रेक्टेंगल या ये ट्रायंगल हो, राइट।
नहीं,
फाइन।
तब भी फाइनाइट नहीं होगा मैम, कुछ कुछ पॉइंट्स निकाल दें बस।
हाँ,
R2 - 1 2 टाइप इस तरह के रेक्टेंगल निकालेंगे तब भी तो वो फाइनाइट हो जाएगा।
इनफाइनाइट हो जाएगा ना।
हाँ।
R2 में से अगर आप रेक्टेंगल निकाल रहे हो तो वो इनफाइनाइट हो जाएगा, राइट। तो आप
यस
इसको
मैम।
नहीं ले सकते हो ना सेट के अंदर।
हाँ।
आपके एलिमेंट्स कहाँ से रहेंगे, यहाँ से रहेंगे, राइट। सो वही हम कह रहे हैं कि द कॉम्प्लीमेंट ऑफ एनी फाइनाइट सबसेट ऑफ R2, मतलब अगर आप कोई भी फाइनाइट सबसेट लेते हो R2 का, उसका कॉम्प्लीमेंट जो है, मतलब ये वाला पार्ट, बाहर वाला पार्ट, ये किसका मेंबर है, ये हमारे टाउ का मेंबर है, राइट।
वैसे
पर
मैम ये डिस्क डिस्क का जो वो है मैम, कॉम्प्लीमेंट है डिस्क का,
हम्म,
तो वो तो इनफाइनाइट है मैम।
हाँ, तो हम इसको ले रहे हैं ना, डिस्क को नहीं ले रहे हो आप मेंबर, आप जी जो बाहर का पार्ट है ना उसको मेंबर ले रहे हो, तो इसका कॉम्प्लीमेंट क्या आ जाएगा, ये डिस्क आ जाएगा।
डिस्क के अंदर जो एलिमेंट्स हैं वो भी तो मैम वो है इनफाइनाइट।
डिस्क आप पूरा ले रहे हो, लाइक अंदर का भी पार्ट ले रहे हो पूरा, ठीक है।
डिस्क अनकाउंटेबल मैम, कुछ पॉइंट्स निकालेंगे मैम, मुझे लगता है कि लाइक 1 2 3 4 इस टाइप से।
आप सिंपली समझो ना, ये आपने R2 लिया है, राइट। इसके अंदर आपने एक डिस्क लिया, इसको एक्सक्लूड कर दो, बाकी का क्या बचा, ये ओपन डिस्क आप ले रहे हो, ओपन बॉल जिसको हम कहते हैं R2 में, राइट। तो इसके अलावा ये वाला पूरा पार्ट बचा, इसको आपने जी ले लिया, बाहर वाले पार्ट को, तो जी का कॉम्प्लीमेंट हो गया आपका ये डिस्क, ठीक है। तो ये जी क्या है, जी क्योंकि उसका कॉम्प्लीमेंट फाइनाइट है, ये तो फाइनाइट
फाइनाइट
है
कहाँ
ना।
है मैम, डिस्क कहाँ फाइनाइट है मैम, उसके अंदर तो कई सारे एलिमेंट्स हैं
हाँ,
अनकाउंटेबल।
डिस्क के अंदर बहुत सारे एलिमेंट्स हैं, हम पॉइंट की बात नहीं कर रहे हैं, हम R2 में है, हम
R2
आर
में
पे
तो
नहीं
पॉइंट्स
है।
भी होंगे ना।
आप एक एक पॉइंट को नहीं देख रहे हो, यहाँ पे काउंटेबल और अनकाउंटेबल कैसे देखा जाता है, सॉरी, काउंटेबल और अनकाउंटेबल हम देख ही नहीं रहे, हम फाइनाइट और कोफाइनाइट देख रहे हैं। आप काउंट नहीं कर रहे हो ना, अनकाउंटेबल पॉइंट्स है, आप वो नहीं कह रहे हो, आप कह रहे हो ये डिस्क फाइनाइट है या इनफाइनाइट है, ये डिस्क फाइनाइट है।
डिस्क एज नंबर मैम की 1 डिस्क है 2 डिस्क ऐसे करके।
ये डिस्क फाइनाइट है, फाइनाइट कब कहते हो आप किसी भी शेप को, जब आप उसको एक मतलब प्लेन में बना पा रहे हो, वो शेप इनफाइनाइट कब होती है।
डायमेंशन से आप बात कर रही हैं क्या,
हाँ,
लाइक कि इनफाइनाइट रेडियस की ये अगर बॉल हो जाए इस टाइप से
हाँ,
कुछ बोल
हाँ,
रही हैं?
हाँ, हाँ, उस तरह से सोचो। आप इसको एलिमेंट्स को काउंट मत करो इसके अंदर के कि काउंटेबल है या अनकाउंटेबल है, आप इस डिस्क की बात करो कि ये फाइनाइट है या इनफाइनाइट है, ठीक है।
यस
तो ये शेप तो फाइनाइट है ना,
मैम,
क्योंकि आप,
टोपोलॉजी तो उसमें नंबर ऑफ एलिमेंट्स काउंट करके हम लोग डिफाइन करते हैं ना मैम, कोफाइनाइट टोपोलॉजी की जो उसका
नहीं,
कॉम्प्लीमेंट
नहीं,
है।
नहीं, नहीं, जो टोपोलॉजी के अंदर जो एलिमेंट्स होते हैं वो क्या होते हैं,
अच्छा।
सेट होते हैं। वो इवन कोई ऐसे शेप्स भी तो हो सकते हैं, आपको कुछ एग्जांपल जैसे असाइनमेंट्स में भी मिल सकते हैं कि आपने जो आपका जो जी है, जो ओपन सेट है, वो एक बॉल है या ट्रायंगल है, ठीक है।
यस मैम।
तो आपको उसको लेना है एलिमेंट, ठीक है।
ठीक है
उस
मैम।
केस में आप
आप
R2
एज ए
में,
ऑब्जेक्ट देख रही हैं, एज ए
हाँ,
ऑब्जेक्ट।
हाँ, उसको एज अ ऑब्जेक्ट देखो कि वो फाइनाइट है या इनफाइनाइट है। आप आर में
यस
नहीं हो,
मैम।
आप R2 में आ गए, राइट।
यस मैम।
सो अगर आप इसको जी ले रहे हो तो उसका कॉम्प्लीमेंट ये जी कॉम्प्लीमेंट आएगा जो फाइनाइट होगा,
यस मैम।
है ना। तो जी किसका पार्ट हो जाएगा, टाउ का पार्ट हो जाएगा,
यस मैम। तो
कोफाइनाइट
इसमें मैम
टोपोलॉजी
जो
में।
ओपन ओपन सेट्स जो होंगे मैम, रेक्टेंगल और ये ट्रायंगल, ये सर्कल इस टाइप के होंगे मतलब।
हाँ, हाँ, मतलब इस तरह के ओपन सेट्स ऐसे, जिसके बाउंड्री ओपन रहेगी। तो इसका कॉम्प्लीमेंट भी तो ओपन ही हुआ। अगर ये ओपन है, जी कॉम्प्लीमेंट ओपन है, तो जी भी ओपन
जी।
है कि नहीं है?
मैम ये इसमें थोड़ा सा इसकी बैक करिए थोड़ा मैम, क्वेश्चन को दिखाइए।
ओके।
बिल्कुल। मैम इसमें जो एलिमेंट्स हम लेंगे R2 के जो एलिमेंट्स होंगे वो तो कोऑर्डिनेट टाइप के होंगे ना मैम, एलिमेंट्स
हाँ,
जो होंगे। तो जो इसके सबसेट्स होंगे वो कोऑर्डिनेट्स को कंटेन करेंगे, जो इसके सबसेट्स होंगे। तो ये ऑब्जेक्ट्स कहाँ से आप लेके आ रहे हैं, मतलब इसमें ऑब्जेक्ट्स होंगे?
कोऑर्डिनेट्स नहीं है वो। एक काइंड ऑफ, जैसे कि बॉल डिफाइन करते हो आप, कैसे बॉल कैसे डिफाइन करते हो? मैट्रिक्स से डिफाइन करते हो ना, डी ऑफ एक्स कॉमा आर,
लेस देन
मैट्रिक्स
आर।
स्पेसेस,
यस।
राइट?
जी।
बॉल कैसे डिफाइन होता है? बी ऑफ एक्स कॉमा आर, डी ऑफ एक्स कॉमा वाई, उसमें कैसे डिफाइन करोगे आप? वो सारे एलिमेंट्स, ठीक है, जिसका डिस्टेंस, वो सारे एलिमेंट्स y या फिर x
डी
ले
एक्स
लो।
वाई लेस देन आर इक्वल टू आर कर।
हाँ, वो सारे एलिमेंट्स लोगे जिनका डिस्टेंस r से कम हो, तो सारे एलिमेंट्स आ जाएंगे। तो वो जो डिस्टेंस ले रहे हो लेस देन r, तो वो फाइनाइट ही आ रहा है ना, इनफाइनाइट नहीं आ रहा है। हम उस टर्म में बात कर रहे हैं, ठीक है? अभी भी डाउट है?
ये मैम ऑब्जेक्ट वाली कहानी नहीं समझ में आ रही।
ओके, सो मे बी हम फिर नेक्स्ट क्लास में डिस्कस करें या अभी कंटिन्यू करना है?
कर लीजिए मैम।
Okay, so others, if it is clear to you, then you may leave. Thank you for joining, and let's discuss जिनको भी doubt है. So देखो, आपको बॉल का डेफिनेशन पता है, राइट?
यस मैम।
V of x का मार क्या होता है? वो सारे एलिमेंट्स लेंगे हम x से, सच दैट सारे y लेंगे जिनका डिस्टेंस क्या हो, लेस देन r हो, ठीक है? तो अगर आपने ये x ले लिया, ठीक है, तो कौन से y आएंगे इसके? और आपने अगर r ले लिया, समझो ये एप्सिलॉन आपने r ले लिया, ठीक है, तो कौन कौन से एलिमेंट्स इस बॉल के अंदर आएंगे?
जो उसके अंदर होंगे मतलब।
हाँ, मतलब जो इस रेडियस के अंदर आ रहे हैं, इवन जो इसके पास भी आ रहा है, उधर भी आपको एक ओपन बॉल मिल जाएगा। ओपन बॉल्स, ये सब का कंसेप्ट अभी नेक्स्ट क्लास में आप डिस्कस करोगे, आपको लेक्चर्स है इसके ऊपर, लेक्चर वीडियोस। तो मे बी उसके अंदर आपको ये R2 वाला कंसेप्ट क्लियर हो जाए, ठीक है? तो
यस मैम।
ओपन बॉल्स क्या होते हैं कि अगर आप इसके अंदर भी कोई एलिमेंट ले रहे हो, तो उसके अराउंड अगर आप एक ओपन बॉल आपका एग्जिस्ट करेगा जी, सच दैट वो इस बॉल के अंदर ही आए, मतलब वो इसका सबसेट फॉर्म करे, ठीक है? ऐसा ये हर एक एक्स के लिए कर रहा है, इस बॉल के अंदर।
यस
तो
मैम।
इस बॉल के अंदर जो भी चीजें हम देख रहे हैं वो फिर भी फाइनाइट है, ठीक है? हम इस वे में इसको फाइनाइट कर रहे हैं, कह रहे हैं, मतलब एज अ पिक्चर देख रहे हो जो तुम, बट इसको रिमेन, इसको छोड़ के बाकी सारा पार्ट क्या हो गया? इनफाइनाइट हो गया। समझ पा रहे हो?
यस मैम।
ठीक है, तो उस टर्म
मैम
में
इसमें
अगर आप,
एक बार, मैम इसमें डाउट ये है कि जो आप जैसे बोल रहे हैं कि ये फाइनाइट हो गया, तो मतलब हम क्या उसमें जब कॉम्प्लीमेंट लेंगे उसमें किसी सेट
हाँ,
का, तो उसके मेंबर्स हम कैसे देखेंगे? मेंबर्स मतलब उसको फाइनाइट कैसे बोलेंगे?
इसका जब कॉम्प्लीमेंट लोगे, मतलब ये सारा आएगा, R2 माइनस ये बॉल,
जिस बॉल जिस। यस मैम।
तो ये R2 माइनस, ये आप B कर दो, ये बॉल कर दो, तो ये आ गया आपका, ये इनफाइनाइट जा रहा है। पर आप अगर ये R2 माइनस बी ले रहे हो और इसका कॉम्प्लीमेंट ले रहे हो, तो क्या मिल जाएगा आपको? वापस ये बॉल B मिल जाएगा ना।
जी। पर ये बॉल तो इनफाइनाइट है ना, इसमें इनफाइनाइट पॉइंट्स हैं।
आपको वो पॉइंट्स नहीं देखने हैं।
यही तो समस्या है, मतलब क्या देखिए।
समस्या ये है कि आपको पॉइंट्स नहीं देखना, आप उसको शेप को देखो कि वो शेप फाइनाइट है या इनफाइनाइट है। ओके, आप अब जब नेक्स्ट लेक्चर वीडियोस आप देखोगे अगले मतलब नेक्स्ट वीक के, तो आपको क्लियर होंगे कि यूक्लिडियन स्पेस में किस तरह से डिफाइंड है, ये सब मेट्रिक
यस।
स्पेसेस से हाँ यूजुअल से कैसे डिफाइंड है। तो आप पहले ना यूक्लिडियन स्पेसेस से किस तरह से डिफाइन होता है, फिर यूजुअल में किस तरह से डिफाइन होता है। आप जो बात कर रहे हैं पॉइंट वाइज वो डिस्क्रीट है, ये कंटिन्यूअस है, यहाँ हम कंटिन्यूटी की बात कर रहे हैं। ठीक है,
यस मैम।
ये कंटिन्यूअस स्पेस ले रहे हो आप। तो इन चीजों का आप क्लियर कर लो, तो फिर हम बाकी चीजें नेक्स्ट क्लास में डिस्कस करते हैं। ओके।
ओके मैम, थैंक यू
ओके,
मैम। नेक्स्ट ट्यूटोरियल कब है आपका?
नेक्स्ट सैटरडे।
थैंक यू।
ओके, थैंक यू फॉर ज्वाइनिंग, you may leave.